Here we go. So on this one, we're going to be checking it out. Ooh, yeah. All right. Composition of functions. So ladies and gentlemen, so far what we've talked about. Okay. All right. So far what we've talked about is add, subtract, multiply, divide, right? Yes? Mallory, you want to move right here? Okay, so you're ready. So add, subtract, multiply, divide. Those are your 4 basic operations, right? All we did is take 2 functions, add, subtract, multiply, divide. We're going to go through a 5th operation, and this operation is what we call composition of functions. Now, the composition function is going to take 2 different forms. We look at like this, and we look at it like this. Oops, we're using H, aren't we?
F-O-H? No, it's F of H.
Okay? Now, you might be looking at this stuff and be like, okay, I understand the addition symbol, that tells you to add. I understand the subtraction symbol, that tells you to subtract. Put 2 variables next to each other, I know I have to multiply. Put one above the other, I know I have to divide. So these dots then, I guess that's what composition means, right? And yes, that's pretty much what they're going to mean. Now, if you guys want me to write a little bit better, I think this makes a little more sense. F of H of X really just means F of H of X.
You just said.
Right? And H of F of X really just means H of F of X. But I'm writing them in this format to try to make a little bit more sense with you. All right? So let's go back through a different function. Let's do F of X equals, let's play the game. Let's see if I can get it. F of X equals X plus 1. Okay? Keep it very simple. Now, so far when you guys first learned about functions, we learned how to evaluate a function, right? So if I said, what was F of -1? You put the -1 in for what?
X.
The X, right? So you said -1 plus 1, and that equaled what?
0.
0. Very good. Then we did, what about if I say F of 7 equals, and you put the 7 in for there, right? Does everybody follow me so far? You guys remember that stuff?
Yeah.
Whatever number you're putting in, which you're composing the function for, you just plug that in for your X, and you solve, right? Okay, so numbers are pretty basic. What about if I did F of C? Where did I put the C in for? Do I still put it in for the X?
Yeah.
Yeah, it doesn't change, guys. What about if I do F of 3y? Plug it in for X. What about if I do F of X plus 2? Do you still put it in for the X?
Yeah.
Yeah, so now you do X plus 2 plus 1. But now in this case, I can actually add the 2 plus 1, which gives me X plus 3. Okay? What about if I did F of G of X? Now, do you guys know what G of X equals?
No.
No. But where do you think you're going to put G of X in for?
X.
The X.
What is G plus 1?
G of X plus 1. What about if I put a house? A picture of a house. Where do you think that's going to go?
For X.
It goes in for X. Plus 1 equals a house plus 1. Do you guys see this pattern? Mallory, do you see the pattern? The thing that you guys need to follow is no matter what I put in this parenthesis, it doesn't matter if it's a number, it doesn't matter if it's a variable, it doesn't matter if it's an expression, it doesn't matter if it's a binomial, if it's a house, if it's another function, it doesn't matter. Whatever I put in this parenthesis, that's what I evaluate my function for. So I plug them in for the variable of my function. Does that make a little sense? Okay. So let's go up and look at what our functions are. So when you guys look at this problem, what am I plugging into f of x? What am I evaluating? This says f of h of x. So what am I plugging into h of x? I'm sorry, what am I plugging into f of x? H of x, right? So what I have, ladies and gentlemen, oh, I'm sorry, I'm not even dealing with an f. I'm dealing with g's. I'm wondering if it doesn't make sense. Sorry about that. I don't know where the f came from. I guess I probably could have changed it on the front, but either way. So, sorry. So what am I plugging into the g of x function? Is the h of x function. So let's write out what the g of x function is. G of x equals 3x, right? But now what we're doing is g of h of x. So what am I going to do with that h of x? I'm going to plug it in for where? The x, right? Equals 3 times h of x. Remember all the red, what I did right there? Whatever you plug in right here, that's what you plug in into your function.
Wouldn't that be x minus 4?
Huh?
Wouldn't that be x minus 4?
So now we look at this and we say, what does h of x equal? Well, h of x equals x minus 4. So therefore, this equals 3 times x minus 4. And now, when you apply distributive property, you get 3x minus 12. Could you, one of you guys just move up another seat, please? So therefore, no, just pass on, move up a seat. So now let's go and look at the h of g of x. So now what you guys can see is I'm plugging the g of x into the h of x function. So let's write out what the h of x function is. So in this case, I have h of x equals x minus 4. So if I was going to say h of g of x, sorry. If I was going to say h of g of x, where would the g of x go into? It's going to go into the what? The x, right? So what we're simply going to do is now put the g of x.
I'll delete it.
G of x minus the 4. All right? So now what we're simply going to do is say, what does g of x equal? Well, when you guys look at this, g of x minus g of x equals 3x. Okay? So now what I'm going to do is I'm going to plug the 3x into for the g of x. So therefore, what this equals is 3x minus 4. And can you evaluate 3x minus 4? No. So therefore, the final answer is going to be 3x minus 4.
All right.